Hello everyone, welcome back. So in this video, we'll be discussing your properties of OLS estimators in multiple regression models. So in the previous video, we had seen how we calculate the values of the estimators using the OLS method. So since my multiple regression function is also linear in parameters, so therefore I use the OLS method to estimate the value of the parameter of the estimators. Okay, so now properties of OLS estimators in multiple regression models. So moreover, or more or less, the properties are very simple to the properties of the estimators in the simple linear regression model. Okay, so let's go through them one by one and very quickly, because you are already aware of these properties if you have read the simple linear regression model. Okay, so the first one is the regression line. In this case, in the case of multiple regression model, it will be a surface or a plane. Okay, there won't be a line, passes through the means of y bar, x2 bar, x3 bar. Okay, so try to read or try to understand this topic in comparison with the properties of your simple uh, linear regression model estimators. Okay, so things would be more clear for you now, because everything is based upon your prior understanding, and you'll have a better understanding if you have a memory of the previous videos. Okay, so this is true. We had seen in the case of simple model also, the line was passing through your y bar and x bar. That is the mean of the y variable and the x variable. Similarly, the same goes for the regression surface here. It passes through the means of the uh, three variables in the case of three variable multiple regression model. So mean in the second property is that mean of the estimated yi, which is equal to yi hat, is equal to the mean value of the actual yi, right? So the proof is also given here. So yi hat is equal to beta 1 hat plus beta 2 hat x2i plus beta 3 hat x3i. Okay, so you can use, instead of, so this is yi hat, so that is why your ui term is not here. Okay, so in place of beta 1 hat, you can use this equation. So that we had discussed. So just a moment. Yeah, this equation. So if you replace using this equation in here, so you will get something of this form, right? In place of beta 1, you have added y bar minus beta 2 hat x2 bar minus beta 3 hat x3 bar plus beta 2 hat x2y plus beta 3 hat x3y. So if I open this up, this is what I'll get. So this is basically my deviation from the mean, right? So this is equal to small x2y and this is equal to small x3y. So yi hat is equal to y bar plus beta 2 hat x2y plus beta 3 hat x3y, right? If I sum and take the mean, right, so summation of yi hat upon n is equal to summation of y bar hat upon n plus summation of x2y upon n plus summation of x3y upon n. So this is equal to yi hat bar, which will be equal to my y bar, okay, because the mean of a constant is itself only, and this term will be equal to 0, because the deviation from the mean and its summation is equal to 0, right? This you have read in statistics. So this is a very simple basic property that is being used. So we have proved that the mean of the estimated yi is equal to the mean of the actual yi, right? So remember this property. Okay, now the third property is a very simple property, that summation of ui hat, or the error term, or the average of the error term, is equal to 0. Okay, the fourth property is the residuals are uncorrelated with x2i and x3i. That is, summation of ui hat x2i is equal to 0 and summation of ui hat x3i is equal to 0. So the residuals, that is the error term, right, it is not related or uncorrelated with the x2 variable and a x3 variable. Okay, that is being also written mathematically or statistically in this form, right? So I hope you remember this property. So the residuals ui, this is the fifth property, the residuals ui are uncorrelated with yi. So the residuals are uncorrelated with your x variable, and they are also uncorrelated with your y variable. Okay, because ui is capturing the unexplained part of yi. Okay, and if they are related, it means that somewhere down the line ui is explaining the yi variable. So this can't be possible now, because it is capturing that part which is not explained by the x variable. So this is a requisite, or this is a property, okay, of your OLS estimator in the multiple regression model. So this is the mathematical uh, uh, mathematical presentation of this particular property, that summation of ui hat yi hat is equal to 0. Now the sixth property is if R23, that is the correlation coefficient between x2 and x3, increases towards 1, the variance of beta 2 hat and beta 3 hat increases. For given values of sigma square and summation of x2 x square of x2i, or x2i whole square, or summation of x3i whole square, this implies it will be different to know the, not different, it's difficult to know the true value of beta 2 and beta 3. So basically this is coming from this formula. Let's go back from here. So if this value approaches 1, R2 3 value, R2 3 value approaches 1, it means that this value, this entire value R2 3 is approaching 1. This implies 1 minus R2 3 whole square is approaching infinity, right? Okay, so sorry, this is reaching 0, and this value of variance of beta 2 hat is reaching your infinity value. Okay, so it will become very hard to estimate the beta 2 hat value or beta 3 hat value if this is the condition that is present. So if R23, that is the correlation coefficient between x2 and x3, increases towards 0, the variance of beta 2 hat and beta 3 hat also increases, and it moves towards infinity. So for given values of sigma square and summation x2i square and or x3i square, it will be difficult or to know the true value of beta 2 and beta 3, because the variance will be very high and you cannot correctly estimate the true value of my parameters, of your parameters, okay, true population parameters. Okay, so if a particular parameter has a very high variance, okay, so you cannot rely on the value of that parameter, right? You cannot be sure what is the true value of that parameter because there is so much variance. That is what is being told by this property. So the seventh property is given R23 summation of x2i square or summation of x3i square, variance. So if these three terms are given, right, variance of OLS estimators are directly proportional to sigma square. So we have seen this. This is also from the same formula that we had just seen, right? So it is proportional to your sigma square. And the eighth property and the last property is basically your OLS estimators are blue given the CLRM assumption. So we have uh, seen the assumptions, and given those assumptions, your OLS estimators are blue, that is best linear unbiased estimators. Okay, I hope you remember this. So this is all for this video. In the next video, we'll be talking about your R square. Okay. So I hope this video was clear, and the properties of your OLS estimators for the multiple regression model are also clear. So I'll see you in the next video very soon. Till then, take care.